In the last video, we talked about how to multiply polynomials. And in this video, we're going to talk about some products that show up often enough that we call them special products. So let's take a look here at the first one. This one says, for any real numbers a and b, a plus b times a minus b equals. So let's look at that for a minute. If we go ahead and FOIL that out, now if you recall our FOIL, that's where we multiplied the first terms, then the outer, then the inner, and then the last. So when we do that with these two binomials, we get a times a, which is a squared, a times negative b, which is a negative ab. The inner terms are b times a, and b times a is the same thing as a times b, as you know. We'll be using that fact. And then here we have, for the last terms, positive b times negative b, which is a negative b squared. So what I want you to see here is that these two middle terms, the negative ab and the positive ba, they cancel. And so what you're left with when you multiply these two binomials is a squared minus b squared. So what you're left with here is a subtraction. So we call that a difference because you have that subtraction sign. And then notice that the first term is a squared, so it's a perfect square, and the second term is b squared, that's also a square. So we call this special product the difference of two squares. And it comes up quite a bit, so you want to look for that one. So again, in your notes, a plus b times a minus b. Notice the binomials have the same numbers. Remember, these a's and b's represent numbers, but with different signs, one positive, one negative. And when you FOIL those out, the middle terms cancel. So you're left with these two terms, and they're both squares, so difference of two squares. Okay, let's look at the next special product. This one says, for any real numbers a and b, the binomial a plus b squared equals. Okay, so let's look at that. What happens when we square a binomial? And again, we're going to use our FOIL. So first, outer, inner, and last. And so a times a is a squared. A times b is plus a positive plus ab. And then b times a, we get a plus ba. And then the last terms, b times b, we get a b squared. Now this time, our middle terms are the same because ba and ab are the same thing. So we have two of them. So we end up with a squared plus 2ab plus b squared. And this is a perfect square trinomial. That's what these are called. Perfect square trinomial. And actually, this one and the next one are both perfect square trinomials because we got them by squaring a binomial. And notice what it is. The first term of the trinomial is this term squared. Then the middle term is take the product of these two, AB, and then take two of those, so plus 2AB. And then the last term is this term squared. So that allows you to do this special product in your head if you know that pattern, and then you don't have to FOIL. Okay? For this time around, we have a binomial we're squaring, but we have a subtraction sign in between. The only thing that's going to change there is going to be our middle term sign. So again, we're going to have a squared as the first term. When we multiply a times a negative b, we get a negative ab, and we're going to have two of those. So we're going to have a negative 2ab for the middle term, and then a negative b times a negative b is a plus b squared for our third term. So both of these, in number 2 and number 3, are called perfect square trinomials because we got them from squaring a binomial. All right, now let's use these special product forms below. Okay, so the first example has a plus 1 times a minus 1. So you may recall that this kind of a format is our difference of two squares. Difference of two squares. Special product, which means that our answer is going to be this guy squared, a squared, minus 1 squared, which is 1. The middle terms are going to cancel if you fill that out. Okay, so there's our answer. All right, let's look at number 2. X minus y times x plus y. Again, we have our special product that is the difference of two squares. So our answer is going to be x squared, this guy squared, minus y squared. Okay, let's go to the next one. This time we have z plus 3 times z minus 3. Again, we have the difference of two squares, so we know that we're going to get z squared minus 3 squared. And 3 squared is 9, so z squared minus 9. And this one, this next problem looks pretty complicated, but notice you've got this term and this term are the same. The 2n squared and the 2n squared are the same. The only difference is that you have opposite signs. So that's how you're going to recognize the difference of two squares. So we know that our answer will be the first term squared minus the second term squared. Okay? And now let's square those. So remember, we're going to square the 3 and the m squared. So we get 9m to the 4th. Minus, and then square the 2 and the n squared, so we get 4n to the 4th. So that's our answer. All right, let's look at this next one. 6x squared minus 7y squared times 6x squared plus 7y squared. Again, this term and this term are the same. This term and this term are the same, and then we have our opposite signs. So that's the difference of two squares, special products, which means that we're going to square the first term minus square the second term. And so 6 squared is 36, and x squared is x to the 4th minus, and then 7 squared is 49, and y squared is y to the 4th. So there's our answer. Okay, let's go to these next ones. These are different. Now we have x plus 5 all squared. We have a binomial squared. So that's our perfect square trinomial. Perfect square trinomial that we had above, right? Okay, and so if you recall, now you could always FOIL these out. You could write two of these next to each other and FOIL them out. Like if you're in a test or an assignment, you can't remember the pattern, you can FOIL. But if you remember the pattern, it goes like this. You're going to take your first term, okay, and you're going to square that, x squared. Then the middle term, you're going to multiply the x times the 5, and you're going to double that. So x times 5 is 5x, and double that is 10x. And then for the third term, you take your 5, and you're going to square that. So 5 times 5 is 25. So that's our trinomial. Okay, let's try this with number 12, because the only difference between 11 and 12 is the sign. You see that? That's only going to affect our middle term of our trinomial. So again, you're going to square the first term, x squared. Now, x times negative 4 is negative 4x, right? And we have to double that for the middle term. So negative 8x for the middle term. And negative 4 squared is a positive 16 for the last term. Okay, one more here. 3x minus 2 all squared. Again, this is a perfect square trinomial. Remember, we're going to square the first term. So 3x squared minus, we're going to double the product of 3x times 2, right? 3x times 2. We're going to double that. And then plus, we're going to square the 2. Okay, so here we get 9x squared And here we get 2 times 3 times 2, which is 12x. So negative 12x for the middle term, and then 2 squared is 4. And there's our perfect square trinomial answer.